Let us now study what is the unit of mutual inductance. Okay, the unit of mutual inductance is Henry. Okay, just like self inductance, mutual inductance also is self, and the SI unit is Henry only. Okay, let us see what is this meaning of 1 Henry. So we learned that earlier that we have two coils like this way. First coil, this is the second coil. The first coil is in the current I1. Okay, and then in the second coil we have flux linkage that is called phi to 1. Okay, and the number of turns in the second coil is N2, the number of turns in the first coil is N1. Okay, all these things we learned. Now from this we'll take the first equation. Okay, so take the first equation, that is we derived earlier, that is M21 is equal to here N2 into phi 21 by I1 here. Okay, so now let's see this case here. So if this I1 is equal to 1 ampere, okay, I1 is equal to 1 ampere, we want to get everything 1, and then N2 phi 21 is equal to 1 ampere, 1 Weber turns, 1 Weber turns. Okay, then what happens is, okay, so everything becomes 1 here. Okay, so what happens is, in this case, you see this becomes 1. Okay, down you have 1 ampere, and then here you have 1 Weber turns. Okay, then you can say mutual inductance M is equal to 1 Henry. Okay, in this case mutual inductance will be equal to 1 Henry. Let's see the definition now. Okay, in this case, okay, let me write for you. Let us now see the definition now. The mutual inductance between two neighboring coils is said to be 1 Henry if a current of 1 ampere in one coil produces unit flux linkage in the neighboring coil. That means you send a current of 1 ampere in the first coil, and the flux linkage, that is N2 phi 21, will be 1 Weber turns. Okay, that is unit flux linkage is the same. This is the definition for mutual inductance. Let's see another way of deriving it. So let us see the second way of deriving the unit of mutual inductance. Okay, so let's see this now. So we take the second equation, that is M2. Okay, take M21 is equal to minus E by di by dt. Okay, in this case we'll have here, that is E2 will get, okay, E2, and then you have here di1, okay, by dt. Okay, here let in this case di by dt, okay, or you can see if also di by dt, okay, is equal to 1 ampere per second. The current changes in 1 ampere in 1 second, and you see that E2 is equal to minus 1 volt. Okay, we substitute this in C. Okay, so when you substitute, what happens is hit here minus into minus 1 by 1 volt by, this is 1 ampere per second. So what happens is minus to minus become plus, so 1 by 1, so that will be equal to 1 only. So we get here 1 Henry. Okay, so then that time we'll get here the mutual inductance is equal to 1 Henry you will get. Okay, so let me write the definition now in this case here, in this side here. I'll write the definition here. Okay, let us see the next definition here. The mutual inductance between two neighboring coils is 1 Henry if a current changing at the rate of 1 ampere per second in one coil induces an opposing EMF of 1 volt in the neighboring coil. Okay, let's see this. What does it mean? So the mutual inductance between two neighboring coils is 1 Henry. Okay, if a current changing at the rate, that is 1 ampere per second, okay, here it is change of 1 ampere per second, it produces an EMF here. In the second one we'll have an EMF here. Okay, so in this case you have here, there will be an EMF. Okay, that EMF is 1 volt in the neighboring coil. Then you can say the mutual inductance between these two is 1 Henry. Thank you for watching.